Hi, mathletes. We are going to talk about two seven-linear quadratic systems. So we've talked about systems of equations, linear systems. Now we are going to include a quadratic. So we'll have a line and a parabola. So how do we solve two equations when one is linear and one is quadratic? I like to solve them using the substitution method. We can also graph. Elimination method isn't super handy unless you have two quadratics. So we can graph and find, remember we're looking for points of intersection. And then we're using substitution method. There it goes. Substitution is another way. And points of intersection, we're looking for an x, y. We are doing the same thing when we use the substitution method. We're either going to solve for x or y and plug it back into the equation and get our ordered pairs. So how many solutions are we looking for? Well, there are three possibilities. Number one, my line could not hit my graph at all, and that would be no solution. Now, if I do the substitution method and I set it equal to 0, I can check possible solutions using b squared minus 4ac, just like we did with the parabola and the x-axis. Because once we do the substitution method, we get everything to one side, set it equal to 0, so we can figure out how we want to solve it. Then I can use b squared minus 4ac, because even though I'm looking for points of intersection, I've set it up to look to see how many times it's going to hit the x-axis. So if I get a negative number, I have no intersection points. Remember, that's no real solutions, so I have no intersection points. So this would be when b squared minus 4ac is a negative number. When b squared minus 4ac is 0, I end up with a tangent line to the graph, meaning my line is only going to hit the parabola at one place. So one solution for that. Again, my line only hits the parabola in one place, and that's called a tangent line. Positive number, two solutions. So I will get two intersection points. When we solve these equations, we are only picking up the x value or the y value when we solve by substitution, so we have to plug back in to find the other coordinate. All right, so there's my two solutions. Again, my parabola could open up or down. All right, so, and my line could have positive or negative slope or zero slope. So how many solutions? We want to solve in two ways. We want to graph, and we want to use the substitution method. So I'm going to use the substitution method. I'm going to leave it graphing for you. You can grab Desmos to graph. We can also graph these pretty quickly by hand. All right, so substitution method, I am going to sub this for y. So this is handy when they're both equal to y. I can just straight substitute. So 3x squared equals 3x minus 2. All right, so I can't really tell anything from here, so I'm going to get everything to one side. So I subtracted 3x from both sides, and I add 2 to both sides, and now I have it set equal to 0. All right, so from here I can try to factor. I can use quadratic formula if I'm trying to solve, but it didn't ask me to solve yet. First, I'm going to tell how many real solutions that I'm going to solve. So I'm going to come over here and do b squared minus 4ac and see what type of number I get. Because if I get a negative number, that means no solution. And I'm not going to keep working if there's no intersection point. All right, so a is 3, b is negative 3, c is 2. So I have negative 3 squared minus 4 times 3 times 2. So 9 minus a bigger number than 9, right? Minus 24. That's going to give me a negative number. That means no solution on this. Right, so I don't need to keep working. I know my graphs are not going to cross, and when I graph this, I could graph super quickly. My vertex is at 0, 0 for this one, and A is 3, so instead of going over 1, up 1, I'm going over 1, up 3, and instead of going over 2, up 4, I'm going over 2, over 2, up 4, normally. Instead of that, I'm going over 2, up 4 times 3, which would be 12. So I have a huge stretch. And then I'm going to go across this axis of symmetry at x equals 0. And then I have my parabola. Again, we can quick sketch this because we know how. You can use Desmos as well. All right, I know how to graph this line. My y-intercept is -2. My slope is 3. So I'm going to go up 3, 1, 2, 3, and write 1. So close, but not going to touch that quadratic, unfortunately. All right, if you think it could possibly touch at 1, we can always plug in a value and see if it will touch when x is 1. So for this one, when x is 1, y is -1. So, yeah. I'm sorry, when x is 1, y is +1, and for this one, when x is 1, y is 3. Not going to touch. All right, so let's look at the next one. All right, so 3x squared plus 3x minus 5, 2x minus y equals 3. This is not ready for substitution, so I'm going to get this one ready for substitution. I'm going to add y to both sides, and then I'm going to subtract 3. So 2x minus 3 equals y. So I am now going to substitute this for this y. So 2x minus 3 equals 3x squared plus 3x minus 5. I'm going to get everything over to one side. So I'm going to subtract 2x and add 3. I'm going to put this underneath my x term. So subtract 2x, add 3, and underneath my number. And now I've gotten rid of those, so that leaves me with 0 on the left side, 3x squared plus x minus 2. And now I can factor if I want to, which would be AC method, to find my solutions, which I will in just a second. First, I'm going to tell how many. I could ask me. So I'm going to do b squared minus 4ac. So b is 1, a is 3, c is -2. And this is great because I have two negatives, which is going to make this positive. So I have 1 plus 24. So that would be 25. Positive number, so I know that I have two solutions. So my graphs are going to intersect at 2 points. All right, so I can do AC method. I can also do quadratic formula because this is the number underneath the radical. So I already have that. That's why this one didn't have any solutions, because if we had tried to use quadratic formula, we would have had a negative number underneath the radical. So opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. So I know b is 1, so opposite of 1 is -1. Plus or minus, we already know b squared minus 4ac is 25 all over 2 times 3. So -1 plus or minus 5 over 6. So I have -1 plus 5 divided by 6, -1 minus 5 divided by 6. So this is going to be -1 plus 5 is 4 over 6. That reduces to 2/3. -1 minus 5 is -6 over 6, which is -1. These are x values, so I come back over here and I have x values at 2/3 and 1. Now I need to find the y values that match that point of intersection. So I can choose either equation to plug these into, and I'm actually going to choose this one that's already solved for y. So 2 times 2/3 minus 3 equals y. So put 2 over 1, 4/3 minus 3. You could throw that on your calculator. So 4/3 minus 9/3. I just put 3 over 1 and found common denominators, so negative 5/3. And then for this second one, I'm going to plug in negative 1 for x and solve. So negative 1 times 2 is negative 2, minus 3 is negative 5. So when I graph this, those should be my 2 points of intersection. All right, so how do we solve a linear quadratic system of inequalities? So we're going to graph this. I've already graphed the parabola, and I'll explain how I did that. I found the vertex of this parabola by doing the opposite of b over 2a and then plugging back into the function to get the y value. So opposite of b over 2a was negative 12 over 2 times negative 2, which was negative 12 over negative 4, which was 3. And I changed my graph, so I'm going to redo this. All right. Okay, so I am going to start at 3. I'm going to plug in 3 to this function and figure out what my y value is. All right, so negative 2 times 3 squared plus 12 times 3 minus 10. So I have negative 18. So 3 squared times 2 is negative 18 plus 36 minus 10. Oop. All right, so 36 minus 28. I just put my negatives together, or you could put these two together, would be positive 18 minus 10 would be 8. You could do it this way, and that's 8. You just have to take the signs in front of the numbers. All right, so I have 3, 8. So I'm going over to 3, and I'm going up to 8. Okay, so now I switched these so I could get this whole graph on here so it wasn't at the very, very top. Let's just go ahead and leave it like it was, because that's how your graph paper looks. So let's just leave it. And if you changed it to 8, that's okay. All right, so 3, 8. If you changed it to count by 2s, that's fine. All right, now I'm going, because a is negative 2, I'm going right 1, down 2. And then I'm going right 2. And normally I would go down 4, but I'm going to go down 8. And then I have this axis of symmetry that runs right through the middle, so I can do matching points on the other side. Since the inequality does not have an equal sign underneath it, we will use a dashed boundary line. And I know this hits the y-axis at 10, so I can dash it down there. And then that would be over here at 10, so there's my parabola. And then I am going to quick graph the line. So I'm going to think about 4x plus y equals 4, and I'm going to find the x-intercept by plugging in 0 for y, and I'm going to find the y-intercept by plugging in 0 for x. So when I plug in 0 for y, for my y-intercept, 4x plus 0 for my x-intercept equals 4. So 4x equals 4, or x is 1. And for my y-intercept, I'll plug in 0 for x. So 4 times 0 plus y equals 4. So y equals 4. Right? So I go to 1, 0. There's an intersection point. And I go to 0, 4. And then I can draw my line from there. if I can get it to go through that point. All right, so I can see one of the intersection points is at 1, 0. Come on. There we go. Is at 1, 0, but the other intersection point is down here somewhere. All right, it's completely off my graph. So I know I know how to solve these though, right? I can change these to equations. And I can solve just like we did above. I'm going to solve this one for y. So I'm going to subtract 4x from both sides. And then I'm going to take this and replace this y with it. And I can find the intersection points, which I'm going to leave this for you to do. So you'll get everything to one side just like we did on the examples above. So I will move the left side over, or you can move the right side over that way. I'd probably move the right side. Wait, why is that a y? That should be an x. I would probably move the right side over and then find the two intersection points. We already know one of them should be 1, 0. So you can use quadratic formula or you can factor. All right, I will see you guys soon.